Welcome. We are at episode 7, where we're programming an NES game here live on Twitch and posting it on YouTube. So the last stream we did, we got the collision detection working where it was more data driven. And then we started implementing some of the physics related to the way the ship moved in space. I use that term physics lightly because it's right now we're sort of applying a velocity to it, but obviously it's if you look at the controls down here on the bottom, it's super twitchy. Now last time I had talked about trying to reduce the overall movement by doing a division, and I had said that we could do a bit shift to do the division, and because of that we would be able to smooth it out. But then I realized with there being negative numbers, I wasn't remembering whether bit shift would work, and if so, what the caveats were there. So we left it out just to get it working with the velocity the way that it was. And so I want to get that taken care of, and then from there, I think we'll do something where maybe we have different game states where you can have a start screen, and then it'll go into the main screen of the actual game. I don't have a title screen yet. I'm still working on some of the art assets and getting some better art assets together, just because I am not an artist, as if you couldn't tell from the ship we're using. But I'd like to get some decent looking art assets together, and then from there have an actual level, kind of scroll down, add some more enemies, add some explosions when you destroy the enemies, or if you hit an enemy, need to add enemies that will fire bullets at the player, or maybe make the flyby do that and have the collision with the player work properly. And as part of that, I think I want to go back and refactor this collision detection a little bit more, which I know is not super exciting in terms of, adding new things to the game. But I mean, from a programming perspective, one thing that I've noticed over the years of programming professionally is that if you are working with some code and you are not afraid to go back and refactor things, that's going to tend to set you apart from your colleagues. Now, obviously, you don't want to do that to crazy extents, and you certainly don't want to do that to make the code super obfuscated and difficult to understand. But there is a certain value in going back and revisiting your code if you think that you can make it simpler. I mean, simpler code is always better in terms of manageability and readability, and coming back to it later if you discover there's a bug in some particular part. I want to look into, I know CA65, which is the assembler, supports what are called scopes, and I believe that you can have scopes that are local, that provide local labels, so we can start simplifying our label names so that we don't have these gigantic long label names, just for the sake of keeping things a little bit easier to read. We might talk about refactoring things in terms of moving some of these things out of the main shooter ASM file. I don't know. We got to see as we go what that's actually gonna look like. This is as much a learning experience for me as it is for you. Like I said in the first stream, I haven't made an NES game before, even though I've programmed a lot of different things. So it's going to be sort of I'm going to try and keep it as moving forward as quickly as possible, but at the same time, there are going to be times where we have to kind of check out what we're doing and revisit it to make sure that we're doing the right thing. So let's get back to the physics here. So what we were doing is we had changed our code so that after we got the control information, we were decrementing or incrementing the velocity on the x and the y velocities. And then in the process loop here, we're actually processing the entity now. And to start off with, we were just adding the velocity to the player's X position or Y position. And so what we had done was, if the we were loading the X velocity into A, and if the X velocity was 0, then we were done. We didn't need to do anything. But if it was positive, we were going to this player remove X because we wanted to subtract from the velocity. Otherwise, we were going to add to the velocity because it was a negative value. And then we wanted to, once we were done doing either the addition or the subtraction of the velocity, we were going to add that to the player's current position. And again, just to kind of revisit it, the reason why is because if this is the player, we're applying, quote unquote physics, where the player has some sort of X and Y velocity, which would be, sort of represented by this vector, right, of their velocity, and we're applying friction here so that the player will not move super quick and not but also not go forever in one direction. And the reason we wanted to do the divide is because right now we're kind of adding to this X velocity and Y velocity up to the minus 128 to 127 range, right? So the X and the Y can both be in this range of values. We're not doing anything to limit that right now. We probably should, but let's start off with getting it so that the movement isn't quite so quick. So when we do the addition, let's see. So we're decreasing it here. So right now we're just adding the velocity regardless of whether it's positive or negative, which is fine because we know that it's either positive or negative, and it would be what we want it to be. But the problem with this approach right now is that we want to so what we want to do is we want to do the divide using a bit shift right now, so that it will not be quite a drastic movement. Now, one of the things that I was hesitating about last week was I was saying, okay, well, if you do a bit shift to the right, you can get a divide by 2. So if you take the number 20 in binary, right, and this is just to recap this is 20 in binary because, right, these are the places, so it's 4 plus 16 gives you 20. And if you just shift to the right, you get 1, 0, 1, 0, which gives you 10, right? And then if you do it again to divide 20 by 4, you get 1, 0, 1, which is 5. So 20 divided by 4 is 5, which is fine. That's pretty obvious if you know basic math. So now, if we wanted to do the same for negative 20, let's take a look at what that looks like. So for negative 20, first of all, we got to do the conversion to 2's complement, right? Which is converting it from a positive to a negative. And so the first thing we have to do is we have to subtract 1 from this, right? So if we're subtracting 1, we're going to carry this 1 over to here to get 0, 0, 0, 0. Sorry, I didn't do that right. So if this is 20, I don't even need to do the math, right? That's just stupid. The 4 becomes 3, so it's 1 plus 2 is 3 plus 16, that's 19, right? So now we have 19, and then we flip the bits, and we get 0, 1, 1, 0, 0, which hopefully, if we add this to 20, we should get 0, because it's 20 plus negative 20. So 0, 0, 0, 0, 0, right? And all those little ones at the top, I'm just carrying the ones. So that's fine. So that's good. So let me write this again so we can compare. And then it was 0, 1, 0, 1, 1, right? No, it was 1, 1, 0, 1. 19 was 1, 1, and then this becomes 0. These becomes 1. These become 1, 0, 0. Right? Okay. Come on. Sorry, I'm confusing myself here because it's a little rushed getting into this. All right. Cool. So how do you do the equivalent bit shift for the negative value? Well, you could do just a shift like you would with the positive, and you'd end up with 0, 0, 1, 1, 0. The problem with that is that that's no longer an accurate representation of the 2's complement, because there's actually more digits here, right? We have the ones here, 1, 2, 3, 4, 5, 6, 7, right? That would be set up here for the binary. So the problem is when you do the bit shift, if you just do a bit shift and you add a 0 here, you've flipped over to positive. So the key is that when you do a bit shift for negative, this has to be a 1 that gets put on the most significant bit instead of a 0, like in the case of the positive number. And we can see this because if we do the trick of flipping it back to the positive value, right, by flipping the bits and adding 1 to it, I messed this up. What did I mess up? What did I mess up? That's annoying. So this is still negative 20, right? Because 19 is, and then you flip the bits and you get 0, 1, 1, 0, 0. Yeah, so what did I mess up? That's all right. So this would shift over, and this would become 1, 1, 1, 1, 0, 1, 1, 0, right? And then we flip the bits, and we get 0, 0, 0, 0, 1, 0, 0, 1. Oh, okay, yeah, I don't know, I messed it up the first time I was trying to do it. So, yeah, so if this is minus 20, and we shift it over by 1, and we add it on the most significant bit. Instead of a 0 like we did with the positive case, we do a 1. If we do the trick of converting it back to positive to look at what the value is, we get 10, right, which is 1010. And if we do it again, we would get negative 5, right? So if we do it again, we get 1, 1, 1, 1, 1, 0, 1, 1. And if you flip it, you get 0, 0, 0, 0, 0, 1, 0, 0. And you add 1 here, and you get positive 5. So that all works out, right? Hopefully that wasn't too confusing. Sorry if I made that a little bit confusing, just trying to draw it out. It's easier it's easier to do it when you're not trying to draw it by hand on the tablet. Maybe I'll go back and do it if that was too confusing. But anyway, my point is that it comes down to when you're doing it for a negative, you got to include the 1 at the most significant bit. So if we go to the opcodes here for rotate right, the one thing that we didn't look at before was the fact that it says the carry is shifted into bit 7 and the original bit 0 is shifted into the carry. So what does that mean? That means that if we are looking at this positive number for 20 if the carry is equal to 1, when we do the shift, it's going to shift a 1 onto here, which is great for negative, but for positive, it's no good. And I think that's probably something that was messing us up before. Excuse me, when we were doing the code to do this last time, it was, if you remember or you go back and watch the video, the ship was moving like crazy. So I think that was probably part of it. So let's do this. Let's... we're going to change this up a little bit, because what we want to do is, if the velocity is positive, we're gonna do a shift where we set the carry, clear the carry, and if the velocity is negative, we have to set the carry so that it moves the carry on to the most significant bit when we do the shift. So if this is all good, this is fine, because we're saying, okay, if let's add a comment here, just so remember, if the x velocity is 0, then we're done. If it's positive, then decrement the velocity, increment the velocity. But before we actually increment the velocity, in the case of the negative, what we would want to do, right, is we want to set carry. So the velocity is in there, so we set the carry and we rotate right. Yeah, so we rotate right. That's going to not rework, rotate right. That's going to divide by 2, right? And then we're going to set the carry and divide by 2 again to divide by 4. Right, and all this is what we're going to put a little note here. Now, xv2, right? So if you're familiar with languages where there's that bit shift notation here, where you want to tell it how many bits you're shifting by, you're going to shift it by 2 bits to divide by 4. And yeah, so this is the negative case. So that's good. We've divided it. We want to now add it. So now we want to clear the carry, add the entity x position to it. We want to store that back into the x position, because we're done with that's the new x position, right? We took the velocity, we added it to the x position, we've moved the ship, and now we've stored it back into x. We're going to increment the x value, and we're saying, okay, x velocity is done. Now for if the x velocity is positive, we want to do the same thing, but by clearing the carry, right? So now xv divided by 2, positive case. Let's put negative case here. Set carry, right? So we're going to clear the carry, rotate right, clear the carry, rotate right. And the reason we need to keep doing the clear or the set is because the least significant bit, so if we're looking at a number, let's say we're looking at a number like 1, there's some other stuff here, but we're shifting off. The first time we do the shift to the right, this is going to get set, the carry flag is going to get set to 0, and the second time it's going to get set to 1. And we want it to be consistent, because we need it to be either a 1 or 0, depending on if it's a positive or a negative. And just to be clear, I should make that an arrow, not a dash, because then it looks like a minus, which is not correct. All right, so clear carry, rotate right, clear carry, rotate right. Now, is there a way to tell it how many bits? No, there isn't. Okay. Clear carry, rotate right, clear carry, rotate. Okay. Right, so, and then same thing here. We want to add to the x position and store it again. All right, so that looks okay, except that I screwed something up and the assembler is not happy. 455. Add carry entities. Entities plus entity X position. See, that's one of the downsides of not streaming more frequently, is that I then forget some of these things because it may not seem like a long time, just a couple of days, but it definitely feels like it sometimes. Range error. Okay, so this means we have exceeded the amount of bytes we can have in here for this to jump backwards to the process entities loop. So what we need to do now is we need to change this and say we're going to jump to the entities loop, and we're going to. So let me explain that a little bit better. I explained that real quick. So in the branch instruction, it is storing essentially an offset to the location that it's jumping to, I believe. We can look. Pretty sure that's what it is. It's not an address. Let's see. Yeah, so yeah, they're relative modes, so they have 2 bytes. So it's the instruction and then the offset. Okay, so if the offset is bigger than what it can do as a signed byte, stop it. If the offset is bigger than what it can do as a signed byte, either minus 128, 128 bytes, or positive 127 bytes, in this case it's minus 133, it can't actually store that instruction because it's using, it would require more bits, right? So what we have to do is we have to change our logic to check for the opposite condition, because a jump will be able to do the jump to whatever address we want. If we go and look, the address is that it's storing is a full 16-bit address, so it's actually jumping to a specific location rather than to an offset. So what we would need to do here is we'd say, okay, right now we're checking if it's not equal to go to process entities. Instead, what we want to do is we want to say, okay, let's jump to process entities so that we're jumping to this location here. And what we want to say is we want to branch if equal to done process entities, right? So instead of jumping, saying a branch all the way back to here, or here, I guess, actually, we want to say, okay, if it's equal, meaning we've hit the end, then go to this, which is a much shorter jump. Otherwise, use the jump instruction to go back to the top of the loop, which you can do because it's just using the address of the label on the cartridge. So that should, okay, that assembled fine. So let's check it out. Okay, good. So that's working. So let's check the X movement. Yeah, that's a lot better. It's not nearly as crazy as it was before. Like you can see, the Y movement is totally out of control. So let's do the same thing for Y so that we can get some better movement here, and then we'll talk about what we've done. All right, so for the Y motion now, where is that? Okay, so now for the Y motion, instead of doing this, we're loading. If it's equal, we don't need to do anything. We can add a similar comment here so that it's consistent. If the Y velocity is 0, then we're done. And then if it's positive, we're going to go to remove the Y velocity. Otherwise, it's negative here. actually, we'll do that in a second. So we want to, let's see, so it's minus. We want to set the carry right here, because this is down to x, y, 2, negative case, set the carry. So we're setting the carry, and then we're going to rotate right, setting the carry, rotate right, clear carry, add y position, store the y position. We don't need to do that additional load. We just need to increase the y velocity because it was negative. And then we jump to player's velocity is done. And then same thing, but opposite here. We can actually just copy that up to the increment. We don't need the increment. Say this is the positive case, so we want to clear the carry, clear, clear, rotate carry, clear the carry, add to the y, store it into the y position, decrement yv because it is positive, and we jump and we're done, and that should be good. And now when we go back into the game, yes, I mean that's still kind of, I feel like that's still much faster than I want it to be, but you can see that the ship doesn't really move. It moves much smoother now than it did before. It doesn't just stop like on a dime, right? It has a little bit of a delay, which is what I wanted. So I don't know, maybe should we divide instead of by 4, we'll divide by 8. Well, let's try it. Let's see what that looks like. And I'll update the comments in a second if it my keyboard is not behaving. Okay. I'll update the clear rotate, clear rotate, clear rotate. Okay, yep. Set rotate, set rotate, set rotate. I'll update the comments if we end up sticking with this. Clear rotate, clear rotate, clear rotate. Yep. Set, set, set. Okay. It's definitely a lot more gradual. I think we could also probably limit the maximum velocity just so that it doesn't ramp up to quite the high value that it's going up to, because it's probably going way too high. Actually, I'm kind of curious if you hold. Yeah, it goes backwards. So you notice it goes backwards at some point, and it's because the velocity eventually rolls over to the negative range, and it'll do that in that direction too. So what we probably want to do is we want to check the velocity and make sure that it's not greater than either the largest negative or largest positive. Pitch shifter, line 465, N is capitalized. Oh, 456. Maybe that was while I was working on it. Yeah, it would have complained. It is case sensitive, so it wouldn't have assembled if I hadn't fixed that. So let's do this. Let's set a maximum velocity. So in the case of the negative, what I guess I want to do is I want to compare it to what's a good, I mean, it can go up to 120. It can go up to 120 and 128 really, and we divide by 8, so 15. That's a lot, right? So even 80 is 10 pixels, which is probably more than we want. I'm thinking, you know, 40 is probably what we want, and we'll get 5 pixels as a maximum. So if we compare it to, and this is the negative case, so bring up the calculator just so I can get the binary. This 1101. Is that D8 as a byte? Right, if I just do that. Right, that's if we just do this manually for a second. So if this is the negative, then we flip it to, and then we add 1, and that's 40. And the only reason I know that so quickly is because if you divide it by 2, that's 20, that's 10, that's 5. It just happens to be a multiple of 5, which makes it easy to see. Okay, so that's right. So D8 is the right negative value. Now, there was something I remembered reading about the comparison with signed versus unsigned on this. 6502 compare signed. It was in this. So I know, so we had done a comparison where we did the branch if equal, branch if carry set, branch if carry clear for the collision detection to simplify that, but that works for signed. And there was something in here that I was reading about that for signed comparisons. Let's see. That's for unsigned. Review of twos. So if you do a load of A and you do a compare, 127 is compare to minus 128. Sign comparisons result in the same. The first number is greater than this, equal or second, but the end flag is different. So what was it talking about here? I may have to come back to this just because I don't want to spend a super long amount of time reading through this and staring at the screen. We can do it for the positive case, and that's simple enough. Right? So for the positive case, it's compare it. Well, before we do anything, what we want to do is we want to compare it to, where's the calculator? Compare it to 40, which is 28 hex, 28, and then if it's greater than, let's see, that's A is greater than or equal to, we want to check the carry flag is set. Excuse me. Okay, so what we want to do is we want to check if it's equal to, then we don't need to do anything. skip forced x velocity, right? And then if it says if the carry flag is set, then it's greater than. So branch carry clear skip forced x velocity, and then all we're doing here is we're going to say load A 28 store A ND entities entity xvx. Right, so what we're doing here is check if x velocity positive is greater than 40. Clamp it to 40. Right, that's what we're doing. So if it's equal, we don't need to do anything. If it's the carry is clear, then carry clear means that it is less than. So if the carry is set, we want to force the value in A to be 40, and then we want to store it back in the x velocity because that's the point that we want as our maximum, and we need that to be in memory. And we're going to manipulate A here to be divided, in this case, by 8. I'm wondering if we need to really do that. I think part of the problem was that the value was just so high. So let's remove the additional bit shift, except that I'm removing the wrong instructions, and that's going to cause a problem. I want to remove the carry, clear carry, this one, and this one. Did I get them all? 1, 2, 1, 2. That should still have a clear carry, so that was just a mistake. This is good. Oh, and here's the last one. I thought I missed one. Okay. So let's check the. I spelled it wrong. 64. All right. So now the x velocity shouldn't get more than, yeah, so it shouldn't, what we should see is that it shouldn't do the thing that it was doing before. Oh, it still did it. Let's see, what did I, oh, well, yeah, of course that's not going to work. I didn't actually, it didn't actually assemble. All right. There. Now maybe it'll do what it's supposed to. So now it shouldn't do that rollover. Yeah, you can see that it eventually maxes out, and even though it's rolling off the side of the screen and flipping back, what's more important is that it's not doing what it did before, where it gets so fast that it eventually flips over the byte, and then you end up with it reversing direction. So that's good. I still wonder if that's maybe too fast. We could even clamp that down a little bit more. We can say 20, which is 16. Let's see. Since we're not doing scrolling of the background right now, we don't really need to allow it to go super fast. Yeah, that seems a little bit better. The other the other directions are a little bit difficult to manage. So we can do the same thing on the positive y value here, and I will, like I said, I don't want to waste time with you guys just staring at me, staring at the screen. So I will look at what I need to do to make this work for the negative comparison case, and then we can get that going correctly in both directions. Right, and then I probably want to make this a constant, the maximum, in case we decide to change it. Max velocity equals 20. Just so it stands out. So now, at least in two directions, we're clamping the motion, or not. Did I compare max velocity branch if equal, skip force Y? Oh, well, it helps if you finish implementing it. Yeah, that should be there. And then story entities. Okay. Right? Maybe? Yeah, that's better. So that motion is a little bit more along the lines of what I was expecting to see the first time. Still probably too fast for what we're looking for, but you know, we can play with it now, and we just change that max velocity if we decide it, you know, should be something smaller. We can mess around with that. It may be that we have to rewrite that whole thing in the first place because it's, or not in the first place, rewrite that whole thing eventually, but you know, that seems too slow, but at the same point, we're not really, there's not a whole lot of screen to work with. Make it 12. Oops. With something like this, you're just basically going to play with it till it feels right. And we'll see. All right. Any questions on that? All right, no questions on that I'm seeing. So let's do something where we now start dividing up the game states into some different states. Like we're going to have a title screen state and a game, like the game running state, and maybe a pause, right, if you press the start button. So what is that? How would that all work? So basically the idea is that the game can be in one of many states. So when the game starts up, maybe it's in, you know, title screen state, and then it transitions to another state, right? And this is gameplay. Now there may be something in between there eventually, like, you know, it shows you how many lives you have or something like that, but that's what we're going to start off with. So gameplay, and then in the gameplay state it will stay there and do its looping. Same thing with the title screen until someone presses start. And in this case, if someone presses start, we're going to go to pause, a pause state, and we're going to wait until someone presses start again, and then we're going to transition back to the start state. So this is just what's called the state diagram. If you've never seen this before, it's just a way of showing what the different states can be and how you transition from one state to another. And it's useful for ensuring that you are properly dealing with all the cases that you want to handle. Like, you don't want to be in the middle of writing your game and then realize that you have no way of getting out of the, some sort of cut screen state or something like that. There's got to be some way to do it, whether it's through controls or through some sort of variable or something, right? So I'm going to put this in brackets to kind of indicate that it's like a button press, I guess. So how are we going to do that? Now, I don't remember if no, I didn't. Okay. So let's add a variable for game state and call it game state. Simple enough. And what I want to do is I want to add an enumeration here, essentially. I want to call out what the possible states are in the game by name rather than by just using a numeric value. I mean, ultimately it becomes a numeric value, but it's easier to write about it, write it out in your code as a name rather than by doing it just purely as a numeric. All right. I feel sneeze coming on. All right. All right, so this is going to be title screen, and then gameplay. The numbers don't actually matter so much as we're consistent, as long as we're consistent with it. And then paused. And that's what we were talking about here, right? There's title screen, gameplay, and pause. So when we start up the game, it's going to already be in the title screen mode or state, because that's state 0. And so what we should do is in our game loop, this doesn't have to change because we're still going to initialize our sprites in memory. Well, I don't know if we'll need the sprites for title screen, for example. What we would need is we do need the controller read. So what I'm going to do is I'm going to move this up so that we do the controller read regardless of state. Since that is going to be useful. And then what I'm going to do is I'm going to change, let's see, this is directly, so this is problematic because it's doing the A and B check and specifically calling add bullets. I'm going to leave that for now. We're going to have to figure out, if we want to do something with that where the controller read is, it may not matter for this because we may not need to do anything with A and B in the, well, actually, that's even, that brings up the point that in the end, the only thing we really need to do is we need to reset the controller state at the beginning of the loop. So let's do that. All that stuff is fine because it really does deal with the actual gameplay state, right? But the read controllers part is, we want that to be common across all the states because we don't want to have to write new code to handle controller stuff every time we add a new state to the game. So we have that, and then what we're going to do is we're going to say, okay, this is going to be we're going to say this is gameplay state title screen state pause state. so compare game state, well, load a game state, compare with game state title screen, right? Branch of equal to title screen state. Otherwise, compare it to game. What did I call it? Game player? That's a terrible name. I don't know why I chose that. Playing game. How about that? Playing game. Should have these. Branch of equal to gameplay state. And then compare game state paused, right? To branch pause state. Otherwise, something is, I mean, we should get one of those, but if we haven't gotten one of those, then something didn't get initialized. Let's problem. Let's just make it loop here. This way, should be able to see what the problem, that there's a problem. Would be even maybe worth doing something where the screen gets updated with like a red, or something that makes it visually obvious that it's not just stuck in somewhere down in the collision or something like that, that is actually stuck in this game state check. But that's okay. Let's leave that for now. So in the case of the title screen, well, so we can do actually a couple of things. Maybe we do the state like this. We say load title screen is 0, and these all get pushed up, right? Because we want to have, what we really need to do is when we're coming in here fresh from reset, we would need to load the title screen, and then the controller in the way. Load the title screen and then transition to title screen, load title. Same thing with gameplay, I guess, right? If you think about it, what we probably want to do is add an intermediate state which says load game, load new game, right? We're transitioned to that using start, and then once that's done, I'm just say done here and done here. And once that's done, it'll actually go into the gameplay state. So load new game. Okay. So that looks reasonable. So the first thing we need to do is we need to fix the this so that it actually checks for those states now. Load title screen. And then load new game. Okay. So load title screen state, load new game state, pause state. All right, so let's start with pause. Pause should be easy. There may be things that we want to do there may be things that we want to do in the sense that we might want the music to keep playing. Similarly, in the transition from the gameplay state to the pause state, we may want to cue a sound, like when you press start in Super Mario Brothers, it does the little jingle. We can talk about that at some point, but there may be something that occurs because of this transition, like a sound. But at its simplest, all we're doing is we're comparing. We're going to load a controller. We're going to compare it against. So let's see. Start is going to be 1, 2, 4, 8, 1. It's going to be value 1 in the second byte, or the more significant byte. And we're going to say, well, not compare. Sorry. We're going to AND it, and if we get not equals, then we know the bit is set, and we're going to branch to well, we're going to do a couple of things. So actually what we want to do, let's check the simpler case. So branch if equal to pause state, right? So if we're in a pause state and the controller the start hasn't been pressed, that means that branch if equal will return true. Will actually branch because the value will be 0 because the bit for the start button hasn't been pressed. So we're going to loop back here. Wait, we don't want to loop back to there. We actually want to loop back to game loop. Sorry. Yeah, we want to loop back to game loop. Because we want to reprocess the controller. If we just loop to pause state, it would loop forever and we would be stuck there. So okay, so now if it wasn't equal, that means that bit was set because the start button was pressed. So okay, we want to change the game state by saying game state playing game, store A to game state, to game state, and then jump to game loop, right? So we've changed the game state here. We've transitioned from pause to playing game. We've stored the state so that the next time around in the loop, it will now go back to playing through the game. For the title screen, we don't have a title screen. I'll have some assets for next time so that we do. There's really nothing to load here. So basically all we're going to do is we're going to load the game state with title screen, store it into game state, jump to game loop. Right? I mean, and this isn't really that different from what it would have done. I mean, all of the main differences here is load title screen assets into character map, right? They so we would have loaded it into. Obviously, it's not doing anything right now. The name table, we would have loaded the assets into the name table so that you actually have a title screen instead of just the frozen stuff that we're loading at the beginning. And so that's the other thing we're going to have to address, and I'm going to do that next time. Is we'll, instead of loading and setting up entities here and loading the star field that we have, we will instead defer that to loading the new game state. Well, maybe we'll do that tonight. It's not that much work to do, so we'll see. Load title screen assets into name table. And then from here, same thing as with the pause state, we're loading controller, we're ANDing for 1, 0 to check if start was pressed. If it's If it wasn't pressed, we're going to go back to game loop. And then if it was pressed, we're going to load the game state to load new game. And then we're going to store it into game state. And then we're going to jump to game loop. And when we go into the load new game, reset assets for a new game, initialize any memory for the player or entities, load tile maps, and then from there we are going to load playing game, store it into game state, and then jump back to game loop. And range error, let's see why. Yeah. Start read controllers, gameplay state initialized. Oh, really? It's going. Well, that's no good anyway. Doesn't need to do that. Branch of equal to finished initializing sprites, sprite init finished. Let's say. So I'm glad it did that, because otherwise we would have been debugging why it was behaving strangely. So it was another out of range error where it was trying to branch to the top here to read the controller stuff, because it used to use that as its branch out of the initialization here. But that's no longer relevant, because now this is the controller information has already been checked at the top. We don't want to go to there. We want to go here so we can start checking for the game state for when you're actually playing. So if we reload that, so nothing is happening right now because the game should be in the title screen game state. So if we hit start, well, nothing happens. What did I mess up? Let's take a look. Let's go to the hex editor. Let's reset the NES. And actually, for the sake of my sanity, we're going to do the same thing we've done other times when we're debugging things. We're just going to move game state to be the first byte in the 0 page, because then I don't have to count bytes to figure out where the heck it is, because since I don't know what is actually going wrong right now. So the value is 6. The value is 6. Well, yeah, so that, okay, so that's a problem. I'm surprised it's 6. Let's see. We're not using 6 for any of the values here in the game state. Let's try forcing it to be initialized. Store a game state to 0. Now it should technically be already happening because of when we, whoa, now it's 9. Okay. Well, it's very broken now. Let me see. I'm even looking to see if the controller is getting updated. It doesn't look like it, so I've really done it this time. Let's see. So here's controller. We'll move it next to game state again to make it easier to debug. And go back to the hex editor. And that's not updating. Okay, so don't full screen that. I assume that what's happening is we just messed something up potentially here. All right, so here's game loop. We're going to start reading the controllers into the controller memory. We're going to load game state into A. We're going to compare the game state values, and we're going to branch each time, and then we have this problem location if it's not one of these. Well, let's use our old trick here of adding the nops. Our no ops will give us a visual clue of where we are in the code, and we can start looking at what got broken by doing what I did. Maybe just something as simple as when I moved some of the code around, I missed a label like I did with the code that was at the end of the initializing sprite, trying to jump up to the controller code. There's how many? I did a bunch of no ops, so it should stick out. Let's see. There they are. Did I scroll past them? The scrolling in this is a little... I'm thinking of switching to Nintaco, which is a pretty decent emulator. What I like about it is it does have... it is cross-platform, and I do use a MacBook for some of my stuff sometimes, and it'd be nice to actually have the same emulator on both platforms, since FCUX on anything other than Windows, the debugging is essentially non-existent. Let's go back to the hex editor here. So this is all good leading up to this. That's what I wanted to see. Did I? Oh, wait a minute. Yeah. So I forgot to use the pound when I was loading these values, and that is probably what the problem is. Let's run. Where's the debugger? And turn off this breakpoint. You're gonna run. Okay. So let's reopen this and look at. Okay, so it should be loading the game states correctly now. Because what I think was happening was because I didn't include the pound, it was loading the wrong values. So, okay, so the scrolling is still happening. Did that happen because I pressed start, or did it happen because... That's weird. That shouldn't be... Why is it transitioning on its own? I mean, it's better. It went from 1 to 3. 1 to 3. Well, I guess that's what it would do if start was pressed. Let's, did I just mess up my logic here? Load a controller. Well, instead of guessing, why don't I just actually look at it in the debugger? Instead of wasting time trying to tease it out. So, let's see. This is not the right part of the code. This is the right, no, that's not the right part of the code either. I have too many no ops now that I've been using for, let's see, so let's get rid of these. Those are no longer necessary. These are the ones that I wanted. Okay. Let's reload that. There we go. Okay. So where are the ones that I'm looking for? There they are. Right there. Okay. So what I want to do, hit the breakpoint here and reload the game. And all right, so if we look at, not the debugger, the hex editor, the value is 0. Load a 0, which is the game state. Step over. The value is store a. Oh, right. Yeah. So, okay, we were forcefully reinitializing the game state, which we don't need to do. Okay, so yeah, here we're setting up sprite mem. That's all good. Okay, so now we're loading A1. We're going to check to... Okay, so now we're checking the controller. We'll get past all of these operations to check the controller. Which nothing is pressed. So it's going to load A with the game state, which is address 0, which is what it did, right? It's going to compare it against 0, which is fine, and then it's going to branch if it's equal, which it would be, to this location. So it's transitioning to 1, right? It's loading A1, which is title screen, because 0 was loading title screen, so now we're transitioning. So we're storing the game state to 1. The value of the game state, we're making it 1, which is what we see here, which is good. We're going to jump back to the game loop. And then we're reprocessing the controller. Okay. Wait a minute. Yeah, okay, well, that's fine. So, so that's, yeah, so that's good. So now the state is 1. I was just making sure that it was actually storing the value in the controller byte. I for some reason thought that it wasn't, but it's fine. So we're going to load A with the value of the game state, which is 1. And then we're going to check it against 0, and it's not equal. We're going to check it against 1. It is. So now it's going to load A with the controller state. It's going to AND with 1, 0. And if it's equal, it's going to jump back to game loop, which is what it's doing. So that's good. So it should just keep doing that. Okay. I mean, that all looks right to me. And then, well, but how or why does it go to the gameplay state? That's the weird thing, because there shouldn't be anything that actually allows it to do that. So what I'm going to do is I'm going to set a breakpoint for if the state is changed. I think I'm doing that right. We'll find out in a second. Yep, so that was where we forced it to be initialized. Okay, so it loaded, so it's going from 0 to 1. That's a state change that makes sense because it's going from loading title screen to title screen. Now it's going from, whoa, why did A become, did I mess up the state transition somehow? Let's see. Title screen, title screen. It's good. Huh. So it's storing the value 3 in A, but I never saw it actually store the value 2, which would be load new game. So it just goes right to new game. So why is that because the NMI is occurring and things are getting messed up, that we're not storing something properly in the NMI routine? Let's see. So one of the things that's what is this doing? This keeps storing 3. Why does it keep storing 3? What is the controller state right now? I feel like I'm just missing something dumb. Controller okay, so it's not actually on a breakpoint anymore. Controller state hasn't changed. Weird. I mean, because it's transitioning to the gameplay state, and that all looks right, but I was expecting it to sit on the loaded assets until I hit the start button. And the start button is, it is 1-0. Although, you know, okay, so part of the problem is going to be that the same problem we had with the A button. So if you remember, I had put in that code to check if A was actually pressed and released, so that it wasn't checking the value every time to determine what to do. It was only checking it on a complete press and release, so that you weren't streaming, you know, an endless stream. Excuse me, an endless stream of bullets. So we're gonna have to do the same thing for the start button, and that's fine. We may want to build that into our game, into the controller checks that are handled for all of the buttons that are not including the D-pad. But why is this transitioning on its own? It's pretty weird. Pretty weird. Right? Because you'll see when we reset the game, the state goes from 1 to 3 on its own, which makes no sense, because it shouldn't it shouldn't do that unless you press the start button. The only thing I can think of is, like I said, that we're checking the controller, but we're getting interrupted by the NMI, and then the result coming out of the NMI has one of the flags set incorrectly. But that's weird, because it should be okay, given that we're storing the processor status and pulling it off. Let me make sure we're doing this in the right order. So it's when we go to push, I went past it. We're doing, let me make sure we're doing the right thing. We're doing the processor status, the X, and the Y. So when we come back out of it, we should be doing it in reverse. Pull Y, right? So it's pulling A and transferring that to Y. It's then pulling A and transferring that to X. I wonder if it's because the processor status is being affected by the pull of the A. Why don't we just really simple reverse the order? Because when you set A, I believe it's going to set those flags. So let's do this. Let's reverse the order, just in case it's something that simple. You never know. I mean, it's logical that that would cause that to occur. No, it's still transitioning on its own without button presses. Oh, it could be this. Let me remove that. That's for debugging purposes. We may need to not do that where we're doing it. Well, still transitioning incorrectly, I think. But weirdly, now it's just sitting here and the controllers aren't getting updated. So, all right, so now it's a different problem. That seems to have potentially fixed one problem, because that increment realistically could be done there, right? Draw complete. Oh, that's why it's not. Okay, wait for draw. Oh, so it does need to do. Oh, wait a minute. It does need to do draw complete, so we can't get rid of that. I totally forgot about that. This isn't getting called at all for the title screen. Which it should be. Wait for... And that's already doing that. So this is still okay, but at least the controller stuff isn't broken anymore. Okay, so that was definitely not what fixed. That didn't fix anything. I mean, we need to increment the complete here because then it tells the game loop that it's okay to continue on to the next loop. But that was only part of something else that was broken by making this change. Because we need to wait for the draw to complete in order for this to loop back to game loop. And then, yeah. And so then we had some states that weren't doing that, which meant that, I mean, that technically we don't want to do it. It didn't break anything per se, but we wanted to be. I wanted to be consistent with that. So I am baffled at the fact that we're getting this problem because I mean, it's pretty straightforward. I mean, the only thing that we're not doing here that we probably should is just zero out the controller every time instead of just rotating everything off. And I don't think that would have broken anything necessarily. Yeah, it's still going, it's still transitioning from 1 to 3, which makes that makes no sense. So why would it do that? Let's think about that. So from 0 to 1 is from load title screen state, right? Which is this. It's going to go to there. It's going to just immediately go to title screen state, store it, jump back to game loop. So now after that's done, it's going to come through. It's going to say, is it title screen? If it is, it's going to go here. We're going to load the controller variable into A. We're going to do a bitwise AND. If it's 0, we're going to go back to game loop. Well, we should... branch not equal... Come on, control, keyboard. Branch not equal, we're going to need to jump to wait for draw complete, but it's not going to be able to do that because I already know that that's too far. So branch if not equal to title screen skip wait. This is jump wait for draw to complete, and then this is ts skip wait. Right, so if it's equal, wait, no, I've reversed that. If it's equal, no, I was right. So if it's not equal, that means the bit is set to 1. In the more significant byte, we're gonna skip the jump there, and we're gonna transition to load new game, store the game state, and then jump to wait for draw to complete. Here we're gonna load the new game state. is playing game. We're going to store it. We're going to jump to game loop. I mean, that all looks fine. I still feel like it has something to do with the NMI occurring and messing with the check of the controller. Or not. That is now sitting on title screen, and now it's in the game state. All right, what just happened? Did I just mess up the comparison here somehow? Other than my mishap with the keyboard, compare the controller with and. If it's equal, meaning it's 0, go to game loop. Otherwise, transition the game state. And I changed it, and I said if it's... Is it because I'm not going back to the game loop? Like, I could have changed this to say, okay, just go to game loop, right? Is that what's making it broken? Debug, hex editor. Yeah, that seems to be what's breaking it. So we'll have to figure out why that is next time, because that's very strange. So I wonder if it's because we're, like I said, we're messing something up in the NMI where it's not handling the popping out of it being interrupted and checking the controller state at the same time is somehow causing a problem. Because you can see as soon as I hit the start button there, it transitioned the right way, and now we're in the game state that we wanted to be in. We're in the playing the game state. If I hit start, that's not doing anything. Oh, right, because I never put it into... Okay, so real simple. Now we can do... right here, we can say load a controller and on 0. Skip, pause. So if it's 0, we're going to skip the pause. Otherwise, we're going to load the new game state, which is paused, store it into the game state, and then jump to wait for draw to complete. Right. So let's look at our hex editor. We're in state 1. Go hit start. Oh, I gotta have to focus on that. Hit start. And you can see that it is transitioning now. But part of the problem is that it's happening too quickly, because again, we're not effectively letting it we're not tracking the button press the right way like we are with the A and B. So what happens is now it's just kind of sticking with one state, and then it looks like the pause is also broken. So pause state and load. Oh, because it's going to the game loop also. So I guess we'll do the same thing here. Pause, skip. Wait. Right? So same deal as what we did up here, where we're going to branch if it's not equal to this, so that we don't jump ahead of time and we actually switch. we transition to the right state. No, I don't want to open that file. Again, we're going to have to make that change for the start button so that we actually can reliably get in and out of pause, because I don't know if you can see it, but it's essentially just flipping back and forth. It's kind of just luck of the draw if you can get it to pause or come out of pause by pressing it fast enough. So we got to fix that, and that will be next time. I mean, we got, the physics are working okay. I got to figure out what the deal is with the negative comparisons. So I'll read up on that, and then we'll do the debounce of the start button. What we'll do is we'll do start, select A and B separately, and we'll put that in, we'll deal with that actually in the controller variable so that we don't have to write special code in our different game state to handle it. We'll just, it'll be set according to the controller variable bits will be set based on whether or not it was pressed and released, not based on just purely the state when the button is pressed in the controller, if it's depressed or released. So before we end for today, let us commit these changes. So we got a lot done. So added game state and state transitions. Need to research why jumping back to game loop causes transitions to occur incorrectly. Maybe related to NMI. Let's see, what else did we get done today? Handled bit shifting on the X and Y velocity, only capping positive velocities. Currently need to cap the negative velocities so that they are not excessive. I think those are the main changes we made today. Oh, should probably make a note of this. Reverse the A and processor state flag push and pull in order to have processor state come out clean from NMI. All right, so stage that and commit that change, and that's that for today. So a lot done. Hopefully we'll get more done next time, and we'll have some assets so we can have a title screen, and then we'll start adding some more enemies and refactoring some of the collision code to be a little bit more generic to handle those more enemies and whatnot. So any questions from anybody still watching? All right, well, like I've said in the past, if you need to find me, I'm on Twitter at Clearvis. You can post comments on the videos on YouTube, and I'm on Nintendo Age and the Nintendo Age Discord. So thanks for watching, and have a good night, and I'll see you Thursday.